Hello, Eigen family. Welcome back, guys. So we've got another episode today. We hope you guys are enjoying your what is it? Christmas Eve.
Christmas Eve.
Right,
or
right.
What's the Seinfeld thing? It's what is it?
Festivus.
Thank you.
Festivus. Yes, thank you.
Yeah.
So you guys may be clued in already. This is kind of a special episode today. So we have our first Patreon interactive episode. So I guess, but just first, guys, if you haven't done so already, make sure you like, share, comment, subscribe as always, and check out the Patreon. It's going to be patreon.com/Eigenbros. And then thank you to all the other patrons who also support the channel. And then, guys, make sure you also check out the handles Eigenbros.com, Eigenbros on Instagram, Eigenbros on Twitter, Eigenbros2 on TikTok. And anything else, Juan? Am I forgetting anything?
I think that's it.
Okay.
Yeah.
So, hello, folks. Our patrons are here. So you guys may finally get to see some of the people who are ride or die supporting the episode.
Hell yeah.
If we could just go down the line, I guess we'll start with Kristaps, and then go on to Tosh, and then Vacuum, and I guess you guys just introduce yourselves.
Yeah, I'm Kristaps Balladis. I'm a first year PhD student at the University of Calgary doing local Langlands program. So basically that means I do some geometry and algebra that makes number theorists happy. I don't know, I don't remember what my Twitter handle is, but I do have a YouTube channel where I make some math content. It's called K Theory. So I figured I'd just plug that as well.
Hell
So,
yeah.
yeah. Oh, I should also mention, quickly want to plug the Prison Mathematics Project, which is a volunteer-based organization connecting people who are incarcerated, who want to better their lives, hooks them up with mathematical pen pals. So you should check out that project as well.
Wow.
Cool.
All right, Tosh.
Cool. So I'm Tash Sharma. Previously a physics class engineering student. I'm now a commercial banker for 7 years in New York City. Don't have anything to plug. I might run for Senate in 5 years, so vote for me if you're in New York.
Hell yeah.
Yeah, what's that?
Tosh for
What's the
Senator.
Tosh?
Sweet. We got the plug in New York.
Yes, sir. Manhattan all the way.
Anything else, Tosh, do you wanted to plug?
No, I'm nothing on social media. Just don't try to find me.
Okay. All right, Vacuum.
we got
Last but
Vacuum.
not least.
All right, so on Discord, guys, I'm Vacuum Decay, but on Twitter, I'm Jack Kraus, and in the real world too. But Twitter handle, not a solipsist, one word. I graduated in May from Loyola University of Chicago, so sorry, New York, but I'm a Chicago guy. I can't, you
Shout
know.
out.
Wow.
But yeah, I'm applying to PhD programs now, second year in a row.
Nice.
But in the meantime, I'm just like teaching and teaching assistantships and elementary schools, high schools, that kind of thing.
Cool.
Excellent, excellent.
I'm about to be on that wave too.
Yeah, that school wave.
Yeah. But by now, when this comes out, we're recording on the night of the 15th,
Right.
when a bunch of undergrads are sweating and maybe tears are strolling down their faces
Poor guys. And
because they have
gals.
so many applications due on the same day.
Right. And turning in all their money now, too. I guess at least they don't have the GRE to do.
No,
It's
no.
kind of a blessing.
Yeah.
But anyway, yeah, thank you guys for the introductions, and you guys have some cool stuff going on, and we appreciate you just coming out and hanging out with us for this special episode 146. So,
So let's get to it. What the hell is going on with science right now?
That's what I ask myself every day. So yeah, I guess I just wanted to start the question, and we'll just go ahead and let it be, kind of open floor, and people can just jump in as they want. So the first question, I guess, was my first question is, what are you guys excited about in terms of, the leading edge of science nowadays? It's about the end of 2021. There's a lot of interesting stuff going on. What do you find interesting that's going on in science right now?
Well, I think my answer for a lot of these questions is going to involve the words automated proof assistance. Um, at least, I mean, this is right now it's more specific to mathematics, but I think very soon it will also bleed over into physics, chemistry, and biology. Um, so the basic idea is like, okay, we already don't trust ourselves to like calculate big numbers in our heads, right? We use calculators nowadays. So if possible, why not do the same thing with our proofs as well, right? We're just humans reading other humans' proofs, and like fields level mathematicians have published papers in top journals that have had to be redacted, right? And like we can't really have this happening anymore going forward. So the basic idea is automated proof assistance. It doesn't prove the theorems for you, but it just gives you that extra check that your logic in each step is correctly verified. There's like lots of cool stuff that has happened with it this last year that's makes it seem it's a lot closer to being like a viable tool that everyone uses on a daily basis. And I think once we have this, I think it will make it. I think we'll have. There's a lot of ways in which it'll improve all of STEM.
Very interesting.
That's what I'm most excited for right now, I think.
I guess I got a question real quick to jump in there. Is this something that you're working on, or just something you're interested in?
No, it's not really. Well, it's outside the scope of my like official PhD research. I spend a little bit of time like reading about some of the theory behind it. There's this really fun game that Kevin Buzzard, who's a big proponent of the automated proof program Lean, it's called. I think it's just called the Number Game. But basically, it's like a fun sort of introduction that teaches you how to use the basics of Lean to like prove some basic theorems. So like I've gone through this and like looked at people's code, played around with the code a little bit. There's a conference in Italy, or it's more like a summer school I'd really like to go to. And it's all about the automated proof assistance and the theory behind it, which is built on this thing called homotopy type theory. So that's happening in Italy, but it conflicts with a summer school more related to my own research. So we'll see. So yeah,
Ooh,
not officially,
choices.
but like something I want to keep my foot in the door about because I think it's the future. So
Hell yeah, that sounds really interesting. We don't have to follow up on that.
That is a huge thing, though. Like, I just saw a paper was redacted from MIT. They couldn't corroborate the results about the Majorana, the topological quantum computer
Okay.
that Microsoft was working on.
Right, right.
They couldn't reproduce the results, and they found out that basically the physicists fooled themselves, essentially. It wasn't a malicious thing, but their lens or analysis was just so, how would you say, the parameters were
Too ill-defined or something?
I think ill-defined is probably not the correct word. It was more, how would you say, constrained than, it was looking at a local.
It was overly constrained.
Yeah.
Okay.
Pretty much.
Well, that's interesting. I'm not sure how well what Christoph's saying would be able to prove that, but perhaps it would have some use. But I imagine yours, Christoph, what you're saying is more of like a mathematical, logical checking device.
yeah, it's more of a mathematical, logical checking device, but. I mean, it's just the early stages. Who knows what sort of things we'll be able to like wrap up and systematize with this. I also think it's going to be great for education. So like this Kevin Buzzard guy, he said he tried teaching an intro number theory course to some undergrads. And okay, it's definitely a bit harder because now you're having to learn how to program in Lean at the same time. But then the advantage is you're getting live feedback. Right? Like, because you're doing your homework and it compiles and it tells you the theorem isn't proved, right away you've made a mistake, right? It's like having the professor like sitting behind you while you're doing your homework and being like, oh no, you made a mistake. So I think there's like cool applications to teaching and stuff too that can come out of it. Yeah.
That's really cool.
Yeah, we need more immediate feedback
Right.
with science and, I mean, just math, really, because sometimes you're just sitting there, you're just like, I don't know if I'm doing this right.
And that's where Mathematica comes in.
Yeah,
So
exactly.
Right.
what I remember hearing about, because I mean I did my major was a joint physics and math kind of major, and like we haven't ever been told about lean, but I mean I've been out for like a couple months now, and I'm hearing about it in almost any science podcast. So
Interesting.
yeah, it's crazy that it's just now coming out.
So Vacuum, since you have the floor, did you have any interesting things that you wanted to see in science, or what you think is interesting right now?
I mean, I guess like kind of on the same note as like the educational track. I mean, seeing like with Zoom coming out and post-pandemic education systems, like how a lot of these, like, so I primarily teach in an elementary school right now. All of these kids are on computers. There are some fifth graders on Discord. I've just found out all of them know about like games like Among Us. So how does that gonna evolve us teaching them how to like use the internet, that kind of thing, and what is that gonna lead to? Are they gonna be more motivated to do something in STEM, or are they gonna be less? I don't know. That's something I guess I'm looking forward to.
Yeah, it's kind of interesting too, because that's kind of something I think that's growing bigger because of the pandemic. From everybody being inside now, we're kind of getting more used to actually doing these kind of online things. I mean, we've already been getting there, but now I think it just ramped it up to the next level in some sense.
Yeah,
So,
you have experience tutoring over
online with Zoom.
Mm-hmm.
Yeah, I mean, it seems it's just so great, right? Because I don't have to even leave my house, and I can literally just be making money teaching someone for a few hours. It's too good of a deal to pass up.
But how effective is it? Do you see any like clear advantage? And I mean, the advantage is obviously logistical, but in terms of like actually reaching the other person on the other side.
That's a good question, man. So I do think there are some things that are lacking. In person is just kind of, it's so good to be in person because you get the direct feedback with people. But I guess it's just I guess what I would just say is the ease of access.
Yeah, because I was going to say you get to see their physical discomfort when you throw an integral. Okay, that's a little too hard.
Right, you get to see them squirm a little bit. No, but I think it's just the ease of access really is a massive perk, because you can be in Botswana or something and I can tutor you with the same quality of education that you may not be able to receive. I don't know if Botswanans have lower quality of education, I'm just saying. So don't come at me, but
They have the best.
right. But yeah, I mean it's just the ease of access is so good. And then you see things like the Coursera courses at MIT and all these things. It just makes education so widely reachable. I think it's just going to get better and better. And then as Vacuum was saying, Discord being a utility in that as well. I mean, I've even done some stuff on Discord where I'll just for fun sometimes answer physics questions just in my own time in the physics Discords, just because I feel like tightening up my own knowledge. So it's like it just gives so much access to people who want to actually learn. But yeah.
One thing too I want to toss in about the like tech and education, and something I think like we need to be doing more is VR, like building things in VR. Like how much in order to get kids into math, like how much cooler would it be if you could like shrink down and literally be in the powerhouse of the cell? Or like you've got to do some double triple integral, but now you can like move the graph around and zoom in yourself. Like I feel like math everything would suck less, be way cooler like if we were embracing the VR a lot harder.
That's actually a cool idea, Kristaps. I didn't even think about that. Like I was thinking about that the other day with
the metaverse, bruh.
Yeah. Just thinking about like the way you could visually see some mathematical operations happen, right? Like in VR, like
right.
You're saying, like you're pinching a function and looking at how we physically take derivatives or something, or what an integral is. Like you can show a kid a picture of what that is, but to sort of have physical intuition for it, I think that's kind of a huge opportunity. Yeah.
And just to quickly interject, Mini Beast, we saw you came in here. How's it going?
Yeah, hey, I was having technical difficulties and I was like, oh no. I might not be able to like even be a part of a conversation, but I thought I'd jump in. So,
No,
Oh,
cool.
well, you're doing it right now. We
Yeah.
are glad to see you.
Sweet.
yeah, I'm glad to be here. I'm so excited. So,
Cool.
Yeah, so I guess also we were just trying to. I don't know if you want to jump in here, Mini Beast. Actually, kind of a good opportunity. We were just talking about what everybody's excited for in terms of current technology and or current science. Maybe you can just give us some of your what you're excited about right now.
yeah, well, I feel grossly uneducated in what's going on in the fields of science. One, because I'm not even in undergrad yet. I'm just like a total enthusiast applying to schools right now. Um, and so I think for me, I've applied to a couple programs with superconductors because I think it's super interesting to see how we can use like these very, very small scales in everyday applications. And it's just really interesting, the development of superconductors over time to me. And it's like a good medley between like physics and engineering. So it seems super interesting. So I'm interested in where that's going. But I guess for me, it'd be more learning about what are some bigger scale applications with people and their day-to-day quality of life that could be improved by technologies with engineering, math, and physics. But that's more learning about it, not about what would I like want to see happen or what do I know about. So
Pretty cool. So you're pretty fresh in the game. The whole world is your oyster, huh?
Yeah.
absolutely.
Yeah, we actually have
That's
an
awesome.
engineer in the chat right now. We got Tosh.
Yes.
Tosh. I'm not sure.
No, Tosh. I think I
cool.
said Tosh.
Previous engineer. I never did my FE. I think that's the exam, right? To be an actual engineer, but I can build anything under the sun.
Oh,
Okay.
Oh, I love that.
man of confidence. I love it.
Yeah. Nice.
But
You're
yeah.
not going to be signing off on any bridge constructions anytime soon.
No, not at all. Now I'm more of a space guy. I'm trying to build rockets and things.
Yeah.
Sweet.
Juan is trying to manually flip between cameras here. Is there a way we can automate that?
I don't know. Discord is kind of funny, but
Yeah.
I'll just keep switching, man.
Oh well, yeah. So Tosh, we didn't get to you yet, man. What's interesting to you right now in terms of science and tech?
Okay, I want to just add 2 points to the things that we were talking about earlier.
Yeah.
Just because anecdotes came to my head. So the first point you guys had about human education, like how it's radically changing. Who is allowed to get educated? Who can educate people when, right? So one of the stories I saw yesterday, Victor Niederhofer, he's like a very famous hedge fund guy, like mid billions, lost billions, but he was paying I think it was like a Sudanese guy, like $10 an hour to teach him some statistics because over Zoom, like never met this guy, just found someone online on email, but that was like the best education he could find for his son as a hedge fund manager in Connecticut. But like because the internet like is cheap, the guy who's teaching is good, it works for him, right? So like it is very magical to see that. And I know what the second point was. Oh, VR. In terms of VR technology, like I think because so much of the development has been on the entertainment side, like we're trying to make more VR movies and things. Nothing's really been done on like educational side. But from my personal experience, I'm a pilot as well, right? So like I have like a VR setup. It literally allows you to be in a plane. Like you don't get that level of like 360 feedback on any mechanism outside of like a Microsoft VR simulator. So I think it tremendously changes again, like back to what Juan was talking about. Like if you could go into cells, if you could see how an equation transforms over time, just in a person in VR. Like I think that'd be magical for education generally. But back to my real point, space. Like I think I'm very excited about space. I think space race is a good thing just for our civilization. I'm not a big fan of, I think, some of again, it's been made into entertainment, right? So like now celebrities are going to space, like hanging around for 5 seconds and coming back down. I don't really think that does much because you're still flying on bullshit Newtonian rockets. But there are companies today who are trying to do newer things with space, like find new ways of propulsion. There was a company trying to build antimatter rocket. I mean, God knows if it's ever going to happen, but I'm generally excited about us being able to think about space differently and think propulsion differently than we used to.
Interesting. So let me probe a little bit. What do you mean by propulsion differently? Because I'm only aware
So
of
if you think of
type.
propulsion today, right? Like what do we do? It's still, you throw a rock outside of a rocket. It's just a rock is liquid matter, whatever it might be, but you're still a very much Newtonian system. And we've had Einstein for 100 some odd years. No one's really done anything with it. Like our clocks are slightly better, maybe, but it's just we haven't really used what we know about the fabric of space-time at all. And I think if we could actually have some engineers, I guess, I mean that's what it takes, come in and like figure out how can we build technologies out of this wealth of knowledge. I mean, like it's astounding how much we know about space-time. We just don't do much with it. And I think that is kind of what excites me more.
Now, Tosh, are you talking about a Gravito drive or a Alcubierre drive?
Maybe, right? I mean, it's again, possibilities are endless. It's just something better than a rocket. I don't know.
That would
Well,
be
did you
interesting.
see in the Discord I posted a paper from earlier this year where they claimed they were basically had set up the Casimir effect for that experiment, and they claimed that they measured somehow the geometry they measured was consistent with what you would expect for the space-time geometry of an Alcubierre or Alcubierre, I'm not sure, warp drive, but it's on like an extremely tiny scale. Which I was very confused about because I thought that you technically needed negative energy densities to do that. And then apparently in the Casimir effect, you can get negative energy densities just from like the vacuum fluctuation. And I read this paper, I'm like, okay, that's cool, but probably not scalable, right? And then, I mean, this is way out of my field. But then I was reading up on the Casimir effect, and apparently you can actually have indefinitely large negative energies coming out of the Casimir effect. I'm going deep into territory I don't really know here, but you should check it out because it's maybe an exciting proof of concept. I don't know.
Very much, yeah. Yeah, it's just a different way of thinking about it. Like I think more of like because every time kind of moves through space time, right? Like everything's moving all the time. It's just more about it's almost like you have a rotational angle to whatever. It's like it's almost like you're turning in space time rather than speeding yourself up. But either way, like I think now that we have so many companies getting in space, there's so much money in space, right? Like you look at the stock market today, like there's a space index now. There's all these companies trying to build near space technologies. So I think we could see pretty cool things come out of it 10 years, 20 years down the line. And kind of similar to like 2000 happened, the dot-com bubble happened, and we got Amazon, Facebook like 10 years later, right? So like it built out the pipeline, put all the groundwork in, and then the real companies come out much later. So I think from like all the garbage today, like something will work. In 10 years time, like we might get to see something magical. So that's exciting.
Yeah.
Yeah, these are all pretty cool stuff.
Yeah.
Not
Well,
gonna lie.
hear me out real quick. I'm gonna entertain you guys.
Juan, you
here
got
for a second.
something?
I do.
Okay, what you got, bro?
Recently, in 2017, I don't know which research group did this, but I think they put a micron-sized object in superposition. It was 2017, I think. This is not the paperclip experiment that I was talking about.
Okay.
This is a separate experiment.
Okay.
So we
a
keep
macro
getting
object
bigger
in
and
superposition.
bigger. Yeah, we keep putting objects in superposition and bigger scales.
Yeah.
So hear me out. What if we put a rocket in superposition?
And
then have
Sounds like a high thought.
and then have it tunnel through a gravitational potential barrier into space.
Or you meet your Kaku, Jesus.
He's going
Kaku's
Kaku
like,
full on.
yeah, Kaku's like, write that down. Yeah.
I mean, I'd have to think about that. But... So is that what you're excited for? Or are you going to use that as your?
I am, yeah. Actually, am very excited, and I mean, quantum information science is something that that has really gotten me kind of just scratching my head a lot, and more interested in study fundamentals of quantum mechanics more and more, especially since we're I mean, this year we did a couple episodes on that with the what is it called? The the problem of the what is that? The lady from Oxford? Researcher?
Kiara,
yeah. I'm brain dead because I've been writing essays for the past 7 hours.
Oh, that was the episode on counterfactuals and all that stuff.
Thank you.
Okay, yeah.
Oh,
Yeah, and just how that has to do with quantum
Yeah, we
information.
were all over the place on that one.
Yeah, we were.
But that was an interesting topic. I mean, yeah. So you're more interested in the theory stuff going on right now.
Yeah, but the bridge from how an experimentalist gets to test these more abstract kind of quantum information stuff. Yeah,
I see. Interesting. Okay, so I guess one thing I'll give, I kind of prepared one for this. So what I'm interested kind of is I wanted to see if I could find something new-ish that maybe people haven't heard of that much and also related to what's currently going on. So, of course, everybody knows Elon is killing the game, doing all this shit with SpaceX. You know, he's basically,
Wait, the Dogecoin
taking
guy?
over the game. Right,
Yeah.
that's the guy. But yeah, so he has basically the space thing, as Tosh was saying. I mean, is just so rife. I feel like with so much to do, and I think that's actually a huge part of basically where humanity is going to be going within the next probably several decades, I would imagine. And what's interesting to me is actually one thing that maybe people aren't aware of, everybody's aware of the rockets and stuff, is Elon is interested in also doing some things with fission reactors as well. So there are these things called SMRs that I recently discovered, where they're called small modular reactors. And Christoph is not nodding his head. I think he's probably familiar.
Yeah, actually, I recently found out my home province is going to be getting a bunch of. They're planning on getting some small modular reactors,
Awesome.
and so I started looking into it. But I'll let you keep going.
Yeah, so they're pretty cool. So basically, it's what it sounds like. It's like these portable versions of nuclear reactors. So a typical nuclear reactor can be on the order of taking up space in terms of like what let's say 1 miles. I'm sorry. I forget the space, but the traditional reactors are really large, and then the SMRs would be about 1/10 the size of that. And basically, they're these things that can fit in the size of in the cargo of like trucks, let's say, and they can transport them basically to these remote areas and certain areas wherever they need be, and you can power like 1,000 homes with just these small reactors. And they're really cool also because they have less potential for meltdown as well. Just the way that they're constructed, it doesn't have the same flaws that the traditional reactors would have, but they have less energy output. So I just thought these were really interesting things, and I guess to tie it back to Elon Musk and SpaceX is because they want to actually use these SMRs to terraform Mars, or not terraform Mars, but at least provide power to Mars, which I guess then you could use to be able to terraform in the future. So it seems like one of these next level steps towards the future of actually being able to colonize Mars or a new planet, even. And that's something I'm really excited for that I didn't really know much about until just, studying for this episode.
Yeah, well, I was going to say, I think...
Oh, go ahead,
So
Tosh.
I would say that could apply to like everything, right? Like we have an energy storage problem generally, right? Like why can't you have an electric plane? It's because the battery weight would be like 70% of your plane. Currently, a regular plane just loses oil, I guess, little jet fuel. Like as you're flying, right? So the weight decreases as you're flying. You don't get any of those savings on an electric system. So if you could have a smaller energy production capacity, that would solve. We'd actually have electric planes. Like if we could have a nuclear reactor on board a plane, which you can't currently.
You know what, Tosh? It's interesting you bring that up because I was watching a video where a guy was saying that back in the day, I'm not sure if you guys are aware, we did an episode on thorium reactors, and there was this huge battle between, whether thorium should be the predominant source of nuclear power versus, the traditional reactors that we have right now that use uranium-235, I believe. And they actually
no,
238.
235.
It's either 238 or 235. I forget now. You're probably right. I thought 235 was the one that they want, but 238 was the shittier version. I'm not sure though.
The one that we got.
Yeah,
Don't quote me on those numbers. Massive grain of salt.
the Walmart. We got the Walmart version. We got the Great Value version.
Right.
Yeah.
But anyway, they actually did a prototype thorium reactor plane apparently with Oak Ridge. And I was like, whoa, that's pretty damn cool. That's like a nuclear powered plane. Never heard of that. It sounds like something out of Fallout. So I was like, damn, I guess if we actually did more with thorium as well, maybe that could even be something in the future. It's kind of an aside, but this realm of nuclear energy just is really more exciting than I actually anticipated.
It's very vogue now. Like I think there's a zeitgeist, you can feel it in the air, like where even the renewable energy people are moving much more towards pro-nuclear, which is not even, I think, like 10 years ago, because people were still scared about the Japanese nuclear disaster and everything.
Yeah.
But a lot of that stigma is slowly wiping away.
Yeah, like for instance, I first found out actually my province was getting these SMRs because there's an environmental organization that I like follow and support typically, but they were hosting like a sort of town hall that was quite critical of the small modular reactors. And I mean, whatever, I have an open mind, so I did some digging. But yeah, I was actually I was pretty impressed looking at the small modular reactor. I mean, yeah, so it's there's no carbon emit. Well, of course, everything involves some carbon emission, the building of the actual reactors. But in terms of like it running, yeah, it's green tech, and yeah, as Terrence is saying, it's like I don't remember exactly how it is, but there's something about the actual structure in the way that the small modular reactors are built that makes them resistant to meltdowns and stuff. And I think it's actually a really exciting piece of green tech moving forward.
Yeah.
But I had one question though.
Yeah.
I was under the impression that we didn't have like working thorium reactors yet. Like I thought that was still something we weren't able to get. But you were saying that they had like a working prototype of a thorium plane?
I won't say for sure it was a working prototype. I didn't dig deep enough to say that, but I think they were at least working on one. And I thought they said it was feasible. Don't quote me though. And Mini Beast, you were going to say something? I'm sorry.
Oh yeah, it was a little off topic, so I wasn't like making it a hard point to say it. But I'm so excited to see how these new technologies are so accessible to people, even like me, who aren't like studying and actively participating in this field. Because even like 3 weeks ago, I was so excited because I found this website called fission.net. Where you could basically put a star in a jar, it was almost like the first step to fission, and like the basic you do a little physics experiment like on your kitchen table with making a vacuum out of a jar, and you get to see this reaction out of like a spherical coil. And it was definitely not a reactor or on a plane, but it is basic principles that the general public now gets to be informed of, if nothing else, the fundamentals of what's being created by people who are experts in their field. And I think it's absolutely fantastic because, at least for me, without the internet, I wouldn't have been able to be informed or like in contact with you guys. And it's so cool because then it breaks down a lot of gatekeeping, I think, and gives access to a lot more people. And it's so cool. It's so
You're so right. And then actually, it's even more crazy, Mini Beast. I'm not sure if you're aware, but you can even do fusion like that. So you can make
I was not. Oh my golly.
Yeah. So that's even crazier because, fusion's like the holy grail of, let's say, nuclear reactors, right? And you could actually do these kind of real simple, relatively accessible experiments with fusion stuff. So next time you're on fission.net, just see if there's a fusion.net
Yeah.
and check that one out.
Intriguing to me. We know all the basic science fair projects where you make batteries out of potatoes and make a light or a clock go. And how interesting would it be if in 20 years we have the cliche experiment of putting a star in a jar, or using a tabletop fusion or fission experiment, and we have like all these different vehicles powered by nuclear reactions, which is so interesting. And I'm so glad we're talking about fusion and fission, because I'm so interested in nuclear reactions that it's really cool to see like discussions about it in like real world applications. So if nothing else, even if I can't add a lot of technical ness to the conversation, I can add a lot of enthusiasm, because it's really fun to watch these technologies unfold, especially like even as a layman, to just be able to conceptualize, be like, wow, look at how this is impacting our day-to-day lives.
Yeah,
Awesome.
well, definitely we appreciate you chiming in. You know, I mean, you may even go down this route. Who knows?
Yeah.
Right.
Yeah, we need more enthusiastic people about
Yeah.
fusion, honestly. We really do, just because there's not enough cheerleaders out there for it.
Right.
Yeah. Like,
And thorium.
Well,
especially.
my hope
Sorry, go ahead.
my hope for going to school is to be able to make anything. To be, if I
Tosh.
can make cool things in my garage, then I'll be content with my education. I love the all these lovely things that we're discovering. So anyway, that was a bit of a tangent.
Hey, I think you got the right idea. I mean, you can do a lot. You can do a lot. More than you may realize, too. So, but yeah, I guess shifting gears here, I wanted to kind of do the inverse question, which may be a little bit harder.
what is that?
So, I asked you guys what you're most excited about,
you're
in terms
least
of
excited
science technology. I guess maybe not what you're least excited about, but I guess kind of
What's
in that
overrated?
vein.
Is you talking about like over and underrated kind of thing?
No, so I'll explain. So I'm thinking, what areas are the most stagnant, or do you think need the most growth? Let's say, what areas would you like to see that actually aren't kind of progressing at the rate that you would have hoped, or maybe that you'd like to just see something go a little bit faster? I see everybody kind of like thinking thinking real hard on this. Christoph especially. Anybody want to jump in?
I don't know.
What needs to
Knee-jerk reaction.
Sorry, go ahead, Mini.
Oh, sorry. My knee-jerk reaction is based in anything that I've put a lot of effort in. I just have discovered neutrinos when I was looking into different types of nuclear decay, and I think they are absolutely fantastic. And the more I looked into them, the more I saw that there's this vague mystery about them. And I would be so interested to see what implication or what we would be able to infer from understanding neutrinos more. And I know recently there was a study that said we can't exactly prove a like a neutral or sterile neutrino, I think. They were like, we're excited that we didn't get our answer from it. And so I don't have a lot of like technical like rigor invested in this, but I have a lot of like emotion invested in it because I've painted neutrinos like all over everything. So it would be super cool to hear down the grapevine like more studies about neutrinos and like this little particle that just dances through everything and minds its own business.
Right, that's really interesting. So yeah, so even to, I guess, add on to that, like what could we even do with neutrinos in the future? It's kind of one of these real mysterious things where it's like you feel like it might be this kind of crazy revolutionary thing if we could find a way to utilize it, really.
Yeah.
But that's a really good answer, I would say, Mini Beast, because I mean it's like it is this real mysterious particle. Like why is it here?
Yeah,
Besides just conserving momentum.
One line of study is sterile neutrinos as a dark matter candidate, and that's kind of like one of the big things that I want to kind of work on is in the cosmology department. Is like, I mean, they could definitely be, and so like I think we mentioned Ice Cube in a couple of different episodes, and that's a huge experiment for neutrino observations. Yeah, it's fascinating.
I don't know enough. I don't know.
Oh, that's beautiful. When you start working on it, make sure to let all of us know on Patreon, so that way I can get excited about it.
Yeah. Just gonna publish all the papers.
Yeah. I don't know enough about neutrinos, except like, especially with correlation to like dark energy and dark matter stuff.
Yeah.
Like
do you know anything more to add on that vacuum at all, or is that not even your area?
So my research was pretty much in black holes and the information paradox. I haven't been able to spend too much time on other avenues of cosmology, but dark matter, dark energy, the hierarchy problem, of course, quantum gravity and string theory. That's all stuff that I've kind of got a surface level understanding of. So I can't go into too much detail.
Can you speak more on what the hierarchy problem is? I've never heard of this. I was like,
considering the large discrepancy between the weak force and gravity, and there's like, again, I don't know too much about it, so I can't really make stuff up. But
right, because it's like, why is it that gravity is so much weaker compared to
the other forces? Yeah, I have heard of this. Yeah.
Right? Is that? Yeah. That's it, right?
Crazy.
Yeah.
Well, because I always wondered about dark energy.
This is.
Go ahead, Christoph. Sorry.
This is something that's always confused me. I remember reading some like pop physics books back in high school about like, and they're like, oh, why is gravity so much weaker than the other forces? That's weird. Like there should be a reason. But part of me was like, well, but what if that's just like that's how it is? You know, like is it like does that need it? Like the forces are I don't know. Like at some point we hit like philosophical bedrock or something, right? At some point you got to take an axiom or whatever. And part of me is like, yeah, I don't know, maybe gravity like it's a different ball game, right? Like maybe it's just different, and that's all we can really say. I don't know.
I think it's because
maybe there's more legitimate reasons I don't understand, but.
Sorry, Mini Beast.
I love that you bring that up. That reminds me of something Alan Adams said in an MIT lecture that electrons are not weird necessarily. They behave in these paradoxical ways, but it's not because the electron is anything weird. What's crazy is that if we get 10 to the 28 electrons together, they behave like cheese. Or they behave like shirts, or they behave like whatever else we see. I'm paraphrasing a little bit. But I think that's on the same vein of what you're saying, Christoph, is that maybe it's not that gravity is this weird thing. It's just what it is. And it's a little bit of a paradigm shift that maybe what's weird is all the ways that we interact with things. So
that's
I think it's point. Just, there's like, gravity is so weak compared to all the other forces. I guess people just want to know why the hell, why does it have to be that way?
Yeah, because we have this sort of like zoological model or like ecological model where every particle maybe fits in a sort of niche, right? Like you think about animals in an ecosystem.
Yeah,
they all fit a thermodynamic kind of. They fill a gap in the ecosystem.
Okay.
So I don't know. I feel like people think gravity is in that same like, well, gravity, why is it down here?
Right. We just want gravity to fit somehow because it just doesn't want to fit.
Because you can explain.
For God's sake, just fit in gravity. We've gone so far in physics and it just doesn't want to cooperate.
Ironically, it was one of the first things we thought we understood.
Right. That's right.
Yeah.
And that actually brings me to so I think I did come up with 3 points about things that I wish there was maybe more going into, and one of them is, I mean, maybe it's a cliche to say this at this point, but a quantum theory of gravity. I mean, in some sense, yeah, a lot's been thrown at it, but something different needs to get thrown at. I don't know why. I have no idea like what, but like. It's annoying to me that we haven't made much progress, or we have in the sense we've come up with all of these different, twistor theory, loop quantum, string, all this stuff, but like We don't know. We don't have one yet. We don't have a quantum theory of gravity. That's one of one of the things. Yeah.
So I guess
We're
more
still working
pointedly.
on it.
Oh, sorry, Vacuum. Go ahead.
No, I was making a quick comment. Just we're still working on it. We have come up with many a theory to say that that's not the case. That this isn't what it is. And we've developed the swampland of theories that cannot possibly, because of these set of contradictions, you cannot formulate a theory that agrees with a weak gravity formulation.
Right. The theories that are wrong can be just as useful as, just getting the one that's right, because it takes a lot of, dead theories sometimes to get to the right one, right?
Yeah, there's a lot of.
That's true. It's true. There's this anecdote I love. I don't remember the mathematician or the theorem, but it was some geometer tried for like 7 years to disprove some theorem, or maybe it was prove the theorem. But he was one of the two things. And then after like 7 years of trying, one day he just decided, oh, what if it's like not true? Like, what if I prove the opposite? And then he banged out the proof that day. And so of course it's made like, oh, he wasted 7 years, right? It's only a day's worth of thinking. Well, no, the reason he was able to come up with that proof is because he had the 7 years of failure behind him. He knew the sort of negative impression like of the mold so well that's what allowed him to prove it on that day, right? So
true.
No, I think that's true. There's merit to the swampland being filled out.
I think the swampland needs to be on a shirt or something. That's something that I would absolutely wear, the swampland of theories around quantum gravity theory or something. That's not very marketable, but
it's just a bunch of skulls and with like the names of different theories.
That's a merch idea. Write that down.
The never-ending story, Swamp of Sadness, just like sucking people down. Like you can't give in to the sadness. The quantum theory of gravity is out there somewhere. It's a very niche reference, but
it works.
Yeah, we're gonna steal that merch idea. So
please don't copyright that.
Yeah. All right, Tosh, what you got, bro?
Not much. I kind of agree with everything. I think there is a lot of, in theoretical physics at least. Like I think we might have lost our ways, or like maybe the universe led us astray in the 1950s. Well, like I don't know what the fuck happened since then. I think we might. I don't know. It's like when I went to school, like everyone was working on string theory. I guess they still are, but I think we need maybe a better redirection. I guess like a reorientation of how do we get to the theory of everything, and also how do we use the theories that we already have, right? Like how do we again use relativity better? I guess like we managed to use quantum mechanics pretty well, right? Like we have cell phones and everything else. We managed to do software really well, but I think as a civilization, like we've kind of stopped making big things. Our buildings still run on Victorian knowledge. Like we haven't really, again, like let's build bigger, better spaceships. I guess that's where I come from.
Now, do you all think that's a technological problem or maybe of a cultural problem? Like,
could be both, right? So it could be like there was a generation. So like I use myself as an example as a smart kid, but like Mr. Feynman, like he was a smart kid, went to work for Manhattan Project, like did all of the things. But like one of the smartest person of our generation is Jim Simon, and he runs a $14 billion, $30 billion hedge fund, right? So the smartest men of our generation have kind of been trapped away, and me being one of the people, by this economic incentive where we're not working on these big problems anymore. And I think that is just setting us back a little bit as a civilization.
So you're saying the Richard Feynmans of the world right now are working at Google and Facebook and
horrible. They're trying to figure out how to sell you ads or trying to make. Like, it's not horrible. It's good money, but
right.
Trying to make another nickel between the spreads, what have you. So we're solving these very neat technical problems. How do you sell you the best yoga pants versus build
Those are
rockets
important
again.
problems, Tosh.
They're trying. Yeah, they're trying to. They're trying to figure out your Bayesian thinking to see what you're probably gonna want in the next 2 or 3 hours. Yeah.
Yeah.
They just optimize
And
ads
they're
so much.
phenomenal at it. I'm not saying they're bad at it. Like, it's amazing how good they are at it.
Yeah,
But
exactly.
if they were doing that, if they were doing relativity, like, imagine how good that would be.
Right. No,
Interesting.
one time I had an ad show up I was hungry, and the ad knew I was hungry. It knew what time I was going to be hungry, and it like sent me an ad for Chipotle, and I was like, oh wow, this is very convenient, but a little bit scary.
Yeah. It's got you tapped down, bro.
Yeah, it does. But
Anyway,
yeah.
That actually relates to the other two sort of things I had, and in the sense that it's about the way that we sort of like distribute our resources or choose to distribute our resources. So like one, I do think it's completely messed up that like we're living in a world where we can have like bullet trains and stuff and like go to space, but there's still people dying of like easily preventable diseases and hunger. And I realize it's not a simple problem. It's not just like, oh, let's throw some resources at it. But like, if we can figure that stuff out, I feel like, we should be able to like clothe and shelter people, like just in general. And then the other part of resource allocation too is like, I think in the context of the way that things currently are, I'm kind of behind some of Sabine Hossenfelder's arguments. Like, she's not a big fan of this new super collider that's being built because she's of the opinion that it's probably not going to push us any further. Like, especially if we don't find anything new at these higher energy levels, and even if we do, there's going to be like an explosion of like too many ad hoc papers trying to explain it. So she was like, there's other cool physics stuff going on, like condensed matter or whatever. Like, imagine if we put those resources from, say, the new larger collider to like other more directly applied sorts of physics, which I agree with. But if we sort of had a better way to think about our resources, and maybe we're less concerned about like scarcity or people needing to make like billions of dollars by selling you the Chipotle ad at the perfect moment, then we wouldn't really have to choose, right? We could like build our new bigger collider and like more funding, like more resources for condensed matter folk, So I think those are the other things that I feel are sort of stagnating. It's sort of like the resource allocation problem for physics in some senses is holding us back.
I see. So it always comes back to politics.
Yeah, it does. But let me piggyback off of what you're saying, Kristaps, because I feel like condensed matter. I mean, I'm kind of biased. Me and Terrence here are biased. We're both condensed matter physicists, but I think high energy physics gets a lot of. It's the rock star version.
It's the hot physics, yeah. Cute boys and girls do. Was it high energy?
Yeah. But it's almost like, I mean, quantum computing is kind of taking the limelight a little bit from them.
Yeah, that's true.
But it's still
not quite there.
Right. It's still like, look at our big, massive, huge colliders, and then they show you like a pretty little chandelier for a quantum computer guy.
It's kind of cool though.
I mean, it's very delicate. Don't touch it. It's just.
But wait a minute. Actually, I didn't even know there was going to be a new super collider. Is this the recent video that Sabina made, Kristaps?
I don't know how recent. Maybe. I mean, I just watched tons of math and physics content on YouTube, so I'm not sure who put out what video when. It's all like a blur of Sabine just like poo-pooing like everything and breaking everyone's illusions about certain topics. But yeah, probably it's a recent, because I do think it's fairly recent that it was like officially approved. Like, there was a proposal, I think, that was on the table for a while, but yeah, I think it's in like this last year is they sort of said like, we like voted, we're going ahead with this. I think.
Mm-hmm.
Gotcha.
I know in the past 2 weeks I had the same video in my YouTube suggested, like scrolling through, I don't know the term, But yeah, I recently saw it too, so I would say it wasn't too long ago.
Okay, cool. I didn't get to watch that one yet, so I literally had no idea we were making a super collider, another one. Is it? They're not just upgrading the LHC, are they? They're actually building a whole new one.
No, yeah, I think they're just building a whole new one. It's going to be bigger, badder, and longer.
Yeah, sounds like a waste of money to me too. LHC's fine. What more Higgs do you want in life?
It'd be funny if they just have a dial. I know this is I've kind of aged myself, but it goes up to 11. It's like, well, this one just
Yeah, they're building a new collider that goes to 11.
it's just a little bit more.
Right.
Oh man.
All right, so I guess let's switch it to us, Juan. Did you have what are you disappointed in terms of what needs to
Well,
hurry
I just
up?
heard they're building a new collider, man. I'm disappointed.
That money should be for us.
Oh, what do you mean for us?
For our physics, for condensed matter people, right? Wasn't that your campaign?
I see it as a what do they call it? A lump sum kind of game. You know, if the high energy physicists get a piece of the pie.
Zero sum?
It's a zero sum game.
I don't know the term, honestly.
Zero sum game, yeah.
Zero sum.
Yeah.
I hear it said by cool people all the time, but I never actually looked up what it meant, so I don't know.
Look at it as a piece of the pie. If they take the pie, it's less for you.
Oh,
Yeah.
I see. That is true, though.
Well, I mean, that's not really how it works, but still, the perception of it in the public eye, I think, is a little bit like that.
But yeah, so what would you say? What's an area of science you want to see, be better, be faster, stronger?
Faster, stronger, Terminator 2.0 version.
Oh, that'd be sick.
Yeah. I mean, quantum computing, man.
Really?
I do.
That is true, huh? Just too slow for you, huh? I mean, that's legit.
Yeah. Believe it or not, yeah, it is.
I mean, it's got a long way, right? Any particular gripes? Be specific.
Well, it does. I mean, I think the bottleneck right now is we're still discovering the proper quantum materials, and I've been reading more about the topological quantum computing, and they think that because of the way the electronic band geometry works, that if you find the right material that exhibits this kind of property, it can be what physicists call topologically protected, which just means that the coherence time can exist for extended periods of time without being disturbed, without the state being disturbed for too long. So this is the ideal state that they would like to preserve. The problem is they haven't really been able to find it in a certain type of in the type of materials that they're looking at.
For the topological one, you're saying specifically.
Right.
Okay.
Right. Because, I mean, if you look it up, it's like, oh, in theory, this is like the type of quantum computing we want. But I think finding the type of material that exhibits these kind of properties is the problem.
I see. So you're thinking that we need to find better materials for quantum computing to get longer coherence times. We got a lot of obstacles in terms of quantum, so I kind of think that's a good choice.
Mm-hmm.
Yeah. And I guess I will close it off. What's my one? I don't even know. I should have actually thought about that while we were talking.
You were engaging with the question.
Yeah, I guess one that I always kind of fall back on is battery tech.
Mm-hmm.
Although I actually just made a tweet, related to they actually I don't even know how I didn't really know this until recently. They actually just made a solid state battery for lithium metal battery.
You're talking about Toyota's thing?
Maybe Toyota's partnered, but it's by a company called Solid Power, I believe.
Yeah, I was looking to invest in stocks for certain battery companies.
Yeah. So that might be one to look at because this is a new solid state battery that they finally cracked how to do. So it could potentially replace the lithium ion batteries. There are some drawbacks, of course, potentially.
So for the listeners, do you know maybe a quick pros and cons of?
Let me read it. So let me read something. So I actually had a good tweet response from a guy. I'll read his response.
Well, let me just say, I from my understanding, lithium-ion batteries are sort of the chemical wet batteries that we see classically, right?
Correct.
They can explode and
Right, and cause fires. They're more dangerous, so people kind of like solid state because it doesn't have that kind of setback. And this battery has been realized, so it actually exists. It is possible to do. They have figured out how to do it. So it's just now a matter of implementing it and making it better. So let's see. So my tweet I put, this is a recent tweet. Well, it won't be when this episode comes out, but basically, let's see what the guy's tweet was. So, oh wait, that wasn't for this one. Damn it.
He's like,
Never
wait
mind.
a minute.
But anyway, I'll just kind of talk about it a little bit. So it's a lithium metal battery. One of the drawbacks they had with the old lithium-ion batteries was, of course, like you were saying, they can catch fire. So there was this problem though with the solid-state batteries where they couldn't get it to work because they would form these things called dendrites. So dendrites would just be these accumulations of charge on one of the sides of the potential. So if you just imagine like the potential as like two capacitors, let's just say, for an easy image in your mind, those charge carriers would accumulate in these weird like dendrites. So if you imagine like a dendrite, like a I don't know if it's called a dendrite in mountains. What's the thing that forms like stalactites?
Stalagmites or whatever.
So it's really like kind of like a stalactite if you think about it like that. And they would form on this capacitor to ultimately where the stalactite would get so long that eventually it would hit the other side of the capacitor, and then you have a short circuit.
Right.
So they found out how to actually stop this from happening by combining two different types of technology for the possible ways of making solid-state batteries in this kind of clever way. So, and it's kind of like a magical thing where it just somehow worked, like many of these inventions, right? And then potentially it's supposed to be able to have really long lifetimes, which is like, thank God. I mean, we've all been waiting for like long life batteries, right? For how long now? I'm not sure if it's going to be able to be transferred into, phone technology or anything like that, but definitely this is something to look at in terms of electric vehicles. I think the companies I've seen working with it are Solid Power. One's QuantumScape, I want to say.
QuantumScape, yeah, that's one.
And they already have partnered with Ford and BMW, I think, as well. I think Solid Power did. So also, if you guys want to buy some stock,
yeah.
make sure you look into that.
Well, I trust Toyota. I will say some investing points. Toyota is actually also developing their own solid-state battery, and they're supposed to come out with it, I think, 2022.
Okay.
But,
yeah, it's going to be interesting. I'm like, ooh, maybe this is why all these people keep talking about EVs now. Like they're like, oh, we're in the game now. You keep seeing all this electric vehicle stuff lately. I'm like, I wonder if this has to do with the solid state tech now coming out. I don't know, but definitely something to look forward to because I'm really looking forward to having electric cars as one of those things for the technology I'm excited about as well.
Yeah, you thought squirrels had a hard time with gas-powered engines try to outrun them.
Now. These squirrels are fucked.
They're not going to hear or see what's coming.
Poor guys.
Maybe there's some sort of dog whistles are at this certain pitch. Maybe there's some sort of squirrel pitch that we can't hear. Just put it on all the cars and on all the EVs.
Stops. You need to make that and patent it, and you'll be a rich man for all the PETA people.
Yeah, so cut that part out of the episode so no one beats me to it.
Yeah, you'll be a hero.
Right.
Be a hero. Yeah.
Cut that part out of my memory because I'm on it right now.
Vacuum's taking notes on it right now.
Yeah.
Excellent. So let's see. What time are we at?
I was thinking of. Sorry.
No, go ahead, Mini Beast. You have the floor.
Oh, okay. I was gonna say while we were talking, I was thinking of another thing. I really wish STEM education was people were as excited about educating kids about these technologies as they are about creating it. Because I feel like one problem that is making just a lot of fields so stagnant right now is the way that math and engineering and physics are portrayed to kids. Which is terrible. It's an absolute travesty. And I would really love to see the heart of math and physics actually be realistically portrayed. to kids because we get exposed to it in kindergarten, but we don't get exposed to how math that has a lot of creative work behind it and a lot of aesthetic beauty to it, and a lot of room for curiosity, or how physics isn't this bland, boring thing, but it's how we can make sense of like why the stars do what they do. It has this room for imagination and creativity, and that's what kids are. And then we suck the life out of it in public schools, and I'm like, what is happening? No wonder people end up going into monetary value fields instead of science, because it doesn't seem to have a lot of like integrity to humans and our like drive. Why do we write poetry? Well, it's like physics is to me like the poetry of science. But I would really love to see that be furthered more.
We're working on it.
I actually have probably too much to say on this topic, but I completely agree. I think it's a very difficult problem to solve because, in some sense, I mean, the people who are most passionate about the subject, right? What do? They go on to try and go for the PhD, grad school, or whatever, and like they oftentimes go up to higher education, and the people who maybe don't love it as much, they're like, I don't need to go that deep, and then they end up becoming teachers. Not that they don't love it at all, but I also do. I try and make this point to everyone that math as a creative, as an aesthetic pursuit, right? Because I think I'm sort of borrowing this analogy from Edward Frankel, but the analogy about if you imagine you were taught painting, right? You had no idea that like portraits existed or like impressionistic, expressionistic art existed. All you knew was how to paint fences and how to paint them in one color. And you were told it was this boring thing. And someone tells you, oh yeah, I'm a painter for a living. You'd be like, oh, that's like boring and dumb, right? But that's kind of what's happening with math. And I think personally that, and physics, I think that math and physics has sort of the opposite problem to a painter, right? So some sort of visual artist, people think, oh, they're so creative, and you just have to be born with this wild imagination. What they don't see is the other 50%, right, underneath the iceberg is actually the technical skill, right? Practicing again and again and again and learning certain tricks and how to combine those certain tricks, right? And I think math and physics, we have the inverse problem where they see all the technical skill, right? But they don't see that big part below the iceberg where it's about creativity, and it's about play. And this comes back to things like the VR and playing around with stuff, or like, getting kids to like pinch off functions and stuff so they can play with the math, right? To make it easier to like play with these numbers and not just, oh, I gotta get the answer right and it's so boring. No, play with it, Yeah. Sorry. Anyways, I pushed up now. I'm gonna keep ranting about this for hours.
Mini Beast.
Maybe did a video on Lockhart's Lament, which is an essay that has a lot of the same concepts you were talking about.
Oh, who did this video?
I think Tibby's. It was Lockhart.
Oh, right. Yes, Tibby's. Okay, cool.
Lockhart's Lament, an essay that's like 25 pages, and I read half of it and was like, oh, I feel this so much.
Cool. I'm gonna have to check that out then.
Tibby's is one we should reach out for the podcast.
Tibby's, she's great. She's cool.
One day. We need organization skills. But there we go. What's our time here, Juan? I don't want to go too far.
We're almost an hour and a half.
All right, excellent. Well, guys, we're gonna wrap it up here. So glad this is awesome, guys. We greatly appreciate you guys coming out. God, I can't speak. I'm getting all emotional. But no, so I guess guys, wanted to close it out. I wanted to just see, what would you guys sum up in terms of like the year, I guess. What can I say? What's your overall prevailing closeout, I guess, for how you feel about progress for the year? Just, I guess, a couple sentences. How do you think we've done so far in terms of, scientific progress, math progress, whatever you kind of think in terms of progress of technology for this year?
In summary,
in particular,
right?
In summary, yes, exactly. I guess we can start with Kristaps.
Well, yeah, just to, I think I'll comment on math specifically to bring it full circle back to my answer of the first question. I think we made a lot of progress in the world of automated proof assistance. Like there was this paper, there was this thing that the mathematician Peter Schulze wanted to prove. It was some essential step, right? Because one of the issues is that people are like, oh, it's proof assistants aren't at the level where it's actually contributing to modern math yet, right? We're not there. And then like a couple months went by and people used proof assistants to solve this thing, and we're talking like the cutting edge. Like Schultz is like one of the top like Fields Medal crazy edge of mathematics guys, and here we have like applications of automated proof assistance. Also, I don't know if you know the crypto coin Cardano, named after a famous mathematician, but that dude also just who started it, he just donated like millions of dollars to start a foundations of math a school basically focusing on automated proof assistance, specifically automated proof assistance applied to computer programs. So I think there's great progress has happened in this last year. Lots of exciting stuff coming for that. Yeah.
Awesome. Who's next? Jump in at your own question.
I'll say for me, I was most excited about the awareness made to people about what's going on. So kind of like how I said earlier, access to people. Like I was able to learn about geometric algebra, I think, from your guys' podcast and a lot of other cool rabbit hole projects. And I think that's really cool, the awareness the general public can get to some of these fundamental technologies and math.
Cool. Tosh, you want to go next?
Definitely. So my perspective kind of comes from finance because I'm a banking guy. But I think 2020 and 2021 and COVID crisis mixed into it allowed for like a lot of acceleration of technology that were already there, right? So Zoom was already around, but then COVID just put it in a hyperdrive. EVs were already around, and Tesla was a thing, but then COVID just made it into, I mean, such a big thing. There's like probably 20 companies out there, 15 are fraud. But even then, like I think it's a very exciting time where like we're moving away from, again, being a very software heavy economy, very much ad selling economy, to now we're trying to build bikes and cars. And I think that's an exciting thing.
Cool. And vacuum?
So, I mean, everything everybody said before is really solid. I think there's a lot of, I think I saw a study on Twitter that like from COVID 2020 and 2021, the number of, I think, particle physics papers declined a little bit, but I think the resounding consensus among the people who were responding to that tweet was that quantity doesn't equal quality, and I think people are starting to kind of understand that a little bit more. Graduate schools aren't requiring the PGRE. A couple of schools aren't even going to look at them, even if you send them. So I think that's really good for people who aren't great test takers or focus most of their time on research. That's just kind of like the physics side. I think the last thing I think I'll mention is just like politically, there's like there's a lot more awareness about cyber warfare kind of stuff coming around, and didn't have too much time to kind of elaborate on that, but like there's being books put out by people from Google who dealt with the 2016 elections, and just seeing how other countries can, do different things, and how we're responding to that and recovering from trying to build up defenses or whatever.
Yeah, I know that's like a huge problem too, the cybersecurity, especially of our energy grid.
Right.
Yeah, COVID gave us a lot of time to really sit and think about things that are important. So
For sure.
yeah.
What did you think was some good progress to sum up the year?
Well, I didn't really like the Nobel Prize award.
Huh?
No, I'm just kidding.
Because you didn't get it?
Yeah, because I didn't get it. No, No, I thought things were looking pretty good. I think early in the year, that's when we got. Well, let me think back. I think, for one, the mRNA COVID vaccine was like such a huge thing that I think was a result of either a mathematical endeavor or some kind of quantum mechanic computing thing, if I remember correctly,
idea.
some simulation thing.
Oh.
It was kind of wild stuff. I hope I'm not injecting fake
Are you
news.
saying
into
the
the
wrong
paradigm.
thing, Juan? I hope you're not. I hope you're not talking about Alpha Zero.
Maybe.
Okay.
Are we talking about Alpha Zero?
It's not related.
Well, whatever it was, I thought that was really cool.
Okay.
Yeah.
But the mRNA thing is really awesome anyway, because, I mean, that's a
Yeah.
whole new way to do vaccinations, right?
Yeah.
Huge. And just the rate at which we came out with that, I
Yeah.
mean, absurd.
I heard that they already had it like cute. Some grad student already had figured it out, and they were just like, "Yeah, get it out there." I'm kidding. But
Nice.
I could believe that.
Oh man.
no, but I heard that
Fake
it was.
news and
Yeah,
disinformation.
exactly. I heard that it was queued up. It was Moderna had something queued up, or a bunch of companies already kind of had it in the pipeline.
Right. This was an opportunity.
Yeah. So.
Awesome. And I guess for me to sum mine up, I would say kind of in line with a little bit of what I believe it was Vacuum maybe was saying with you were talking about defense and everything, and kind of I guess it made me think of like satellites and things like Elon Musk, of course, once again, Time Man of the Year. I mean, he's doing big things. His whole Starlink thing is really awesome to me. I think it's just a lot of great progress in terms of trying to bring the internet to the world. I think that is something that's definitely something that I think I'm pleased with seeing how at the rate at which it's going.
He's just he wants it to be like, I bet you anything he wants to have the most Twitter following in the world with the Starlink program.
That's his whole motivation.
Yeah. He's going to be like Tom of MySpace, but for Twitter. Like, you automatically follow him.
Yeah, well, Starlink's pretty badass. I wouldn't even be mad. But yeah, I mean, of course there's some gripes with astronomers, but they'll be fine. James Webb's telescope's coming online soon, guys. Hold your horses. You'll be fine. But anyway, awesome, guys. I think that's the episode.
Yeah, this was a lot of fun.
Yeah.
Thank you, everybody, for coming out, making time.
Indeed. And I
but
guess,
Thanks for having us on here.
Cool.
Absolutely.
This is cool.
yeah, well, we greatly appreciate you guys. Once again, you guys always support the channel.
And for the
you guys help make it happen. So
for the folks listening, thank you for listening and watching. Don't forget to
Indeed.
like, comment, share, subscribe.
100%. Check out Eigenbros.com, Eigenbros on Instagram, Eigenbros on Twitter, Eigenbros2 on TikTok. And yes, and then once again, thanks to the patrons, the guys and gals that are supporting us that aren't here right now. We greatly appreciate you, of course, as well. And I guess, is there anything else, Juan?
I think that's
should
it.
we say?
Happy New Year's to your folks.
Yeah, actually, happy Christmas Eve for when this episode comes out.
Oh,
so.
true. Yeah.
And then Happy New Year's. I think this will be the last episode as well
Of the
for
year,
the
yeah.
year. So
Yeah.
until next year,
Until
then I
next
guess,
year.
guys, right?
Yeah.
And
Anyway.
sayonara to you guys as well.
Bye, everybody.
See ya.